In this question, for the first order reaction, show that the time required for 99% completion is twice the time required for the completion of 90% of the reaction. It means that here, if we have any reaction A and it forms a product B, so based on the two different time intervals, the completion rate of the reaction is different. So if we consider when the reaction just started, that time the time is 0, the concentration of A was R naught. But after a certain time, T1, when the reaction is 90% completed, so during that time, the product left for the reactant will be R naught minus 0.9 of R naught. So we can get this value when we do the 90%, means 90 by 100 into R naught. So that much amount of the concentration is removed, means it will form on the product side. So the value is 0.1 R naught. So this is our R value for the time of T1. Now, if we take the time is T2 when the reaction is 99% completed. So here it is 99 by 100 into R naught, 0.99 R naught. So we subtract with the total concentration, it's R naught minus 0.99 R naught. So the value left is 0.01 R naught. Now based on this, we have to relate that the time T2 is equal to 2 times of T1. This one we have to show or we have to prove. So in the question, it is already given that it's a first order reaction. So if it is a first order reaction, we can use the rate constant formula for the first order reaction. So K is equal to 2.303 divided by T log R naught by R. So let's substitute the value when 90% of the reaction is completed or when the time is T1. So based on this value, K is equal to 2.303 divided by T1 log R naught by R, and here the R value is 0.1 R naught. So we substitute the value 0.1 R naught. Now R naught and R naught gets cancelled. So K is equal to 2.303 divided by T1 log 10. Log 10 is equal to 1. So K is equal to 2.303 divided by T1. So T1 is equal to 2.303 divided by K. So we got the relation of T1 and the rate constant. Similarly, for the 99% completion, the formula is that time is T2. So we can write the formula K is equal to 2.303 divided by T2 log R naught by R, and here this R value is equal to 0.01 R naught. So K is equal to 2.303 divided by T2 log R naught divided by 0.01 R naught. So this R naught gets cancelled. K is equal to 2.303 divided by T2 log 100. Log 100 value is equal to 2. So this K is equal to 2.303 divided by T2 into 2. So we can write T2 is equal to 2.303 divided by K into 2. And we know that this relation is actually a value of t1. So can we substitute the value t2 is equal to t1 into 2, or t2 is 2 times of t1. So this is our answer.